everyone, and welcome back to R&M LAB GH. Today, we're here to dive into a project that combines creative electronics and precise carpentry, the construction of our unique useless box with surprise. It's not just a gadget, but a true exercise in mechatronics engineering, accessible to everyone and based on the reliable Arduino platform. I am presenting a very useful project for working with Arduino and at an electronic level. This is a very handy tool in a lab, whether you are just starting out with electronics, studying in this field, or simply creating DIY projects as a hobbyist. With this small, low-cost instrument, built with Arduino, we can verify the functionality of LEDs in real time, understand what voltage they operate at, and determine which resistor to apply for any voltage we want to use. In short, without having to perform mathematical calculations, this small and useful project allows us to calculate the required voltage drop for the LED in real time, based on the output voltage, with their variability ranging from 5 to 50 volts. The circuit is very simple and requires very few components: one Arduino Mini, one breadboard, some jumper wires, a 16 by 2i2c display 16th forward WC, one push button, two resistors, 470 ohm $470 /omega $, one rotary encoder, and a small piece of female strip header to accommodate the LED pins for verification. I have prepared the complete connection diagram, which you will find in the description. I'll leave you to watch the video, and we'll catch up once the assembly is complete. Now, as always, we move to the computer. Let's connect the USB cable between the Arduino and the PC, open the Arduino IDE development environment, and upload the code which, as usual, you will find in the description. Make sure that the correct board and communication port are selected. Once the code is finished uploading, we will proceed to check the functionality of our project, and right after, I will explain in detail how it works. Here we are. Now we test our project. As you can see, by inserting the LED into the designated contacts and pressing the button, the LED flashes briefly. This indicates that the LED is working. Very important, whichever way we insert it, it functions. It does not require the correct polarity. The display immediately gives us the operating value, or forward voltage, of that LED, which, as you know, changes based on its color. By turning the rotary encoder, we can set the required voltage for our projects, starting from 5 volts all the way up to 50 volts. For example, if we need to connect an LED to 12 volts, we set 12 volts and press the button. The display will give us the result, which resistor to use for that LED at 12 volts so we do not burn it out. And this applies to any voltage. If we set 24 volts, it will give us the suitable resistor to apply to the LED. As you can see, it is very fast and extremely useful. I consider this a fundamental tool at any skill level. Please note, the instrument provides you with the closest resistance and the standard one. These values must always be rounded up. For instance, if it gives you 459 ohm, the next standard value is 470 ohm. And that is all there is to it. Thank you for watching the video until the very end. I hope it was both interesting and useful. Please subscribe to the channel, leave a like, and turn on the notification bell. Leave a comment below, and if you have any ideas for new projects, they will definitely be taken into consideration. See you in the next video. Goodbye.